So we are at the experiment number 10 about momentum and collision. In this experiment, you will observe two kinds of collision, which is elastic collision and perfectly inelastic collision. When you have elastic collision, both momentum and energy will be conserved. If you have perfectly inelastic collision, only momentum is conserved. Therefore, you need two objects. One object, number two is the object to be hit. Number one is the object that will come to hit object number two. On the objects, you have mass written on normally. Mass is in gram, 5 significant figures. You have to change it into kilogram with 5 significant figures. First, you observe elastic collisions. What do we mean by elastic collisions? It means it hit one another and it bounces away. So maybe you can put a stick on one object and you will put a flat object like this in another one. When they become collide, they will not stick with one another, they will just separate. And the momentum and energy should be conserved. And we will launch this object using a magnet. Therefore, on another side, you put a magnet in like this. Here. You switch on both equipment for the attract and for the photo gate. You have two photo gates. I have to switch off the attract first. You have two photo gates. These two photo gates should be 50 centimeters apart, 50 centimeters. Be sure that the objects can pass the photo gate. Both objects can pass the photo gate. The height is right. Okay. So approximately 50 centimeters. For the mode, you select this one, the fourth one that I written. Sorry, the sixth one that I written in the presentation. You select the one that will have arrows moving out and arrow coming in. You arrange it to be around 50 centimeters. So approximately this one is 70, this one should be 120. Be careful that when you obtain the collisions, you want both objects to be inside the photo gate. You don't want the first object to be in the photo gate during the collision. Therefore, the second object should be around here. So that when the first object comes, the collision happens, both objects is inside the photo gate. We will put additional mass in the object. One mass is 50 gram, 5 zeros. In the first case, you put all of the 4 mass on second object. 100 on one side, another 100 on another side. So now we are ready to do the experiment. Before doing the experiment, I would like to check that the photo gate is counting. So I put my hand in. It is not count, so maybe I click reset. Not yet. I click set here. Set. Okay. Should work. Nice work. And I removing my hand, it stop. So it's working. This one is not working, so I click set, reset, my hand in, my hand out, we start and stop. We select the 6th mode. That means each photo gate will count twice. Let's take a look. I move in and out, this count the first time. I move in and out, this count the second time. I move in and out, this count the first time. I move in and out, count the second time. So that is the meaning of the 6th option. 2 arrows in, 2 arrows out with the notation 1 and 3. That means each photogate can count twice. So let's take a look why we need the option to measure the time twice. The object is here, the first one is there, I put the attract on, and I will launch the object. I will press this button and launch the object. Hup. Okay. So I have the first object coming in, that is the time of the first object coming in. Then the first object bouncing back, that is the time that is bouncing back, passing the same sensor. And this one is the time that this object, the second one passing the second sensor. Be careful that when these objects bouncing back, the velocity, the speed, when you calculate has to be minus because it goes back in the opposite direction. Then let's do another experiment. When I move 100 grams from the second object to the first object. So now both objects having the same mass, more or less. I put this one back. The magnet is ready. Both objects having the same mass. Let's see what will happen. The first case that we just did, the first one having less mass, so it's bouncing back. Now they are having the same mass. So what happened? I click reset. I'm putting on the attract, and now I will click that one and use this experiment. You see that you actually see that the first object stopped after the collision, and the second object take all the velocity and moving. The first one stop, the second one take all the velocity and moving. That means it is exactly matched to the theory that when the mass is equal, the second one take all the energy, the first one stop. Therefore, in this case, we have only 2 values. The first one for the first object coming in, the second one, this one, for the second object coming out. Let's do the last cases that all the additional mass is in the first object. So now the first object is very heavy compared to the second one. Should be ready. The second object coming here, reset. So now I will launch the object that is very heavy, the first one. It will hit the second object. I will click launch. I will see the experiment together. So now you see the third case. What happened is that the first object that is heavier will follow the second object. So for the time, the first one is the time of the first object coming in. This one is the time of second object coming out. This one is the time of the first object following the second object. So be careful to note the good time in the good bracket. And that is our 3 cases for elastic collisions. For inelastic collision, you do exactly the same, but you change the connection to this one, so that they will stick together after collision. You may put the needle here, and you put the rubber here. They will stick together after collision. I do it for only one case, but you have to do all 3 cases. 200 grams here, 100 grams here, 100 grams here, and 200 grams here. You will do all 3 cases. Okay, it's ready. I click reset. I click reset. I put on the attract. And you will see the experiment together. Okay? they are stick together and following one another. The first one is the time of the first object coming in. This one is the time of the second object. This one, this guy, passing the second sensor. This one is the time of the first object. This guy, passing the sensor. They are quite comparable because they are become the same object at the moment. So finally you will calculate two velocity and use the average. And that is the second part of the experiment. Remember, you have to do all three cases. When ball to kilogram is here and when ball to kilogram is here. So that is experiment number 10, momentum and collision. I hope that the information today will be helpful to you when you come to the lab to record the experimental data. Thank you.